Hi, I'm Xi. Running apps in the cloud, you know we need to give them the right amount of power, CPU, and memory. But it's a constant headache, right? Set limit too low, your app crash or become painfully slow, bad for users. Set limit too high, you waste a ton of money on cloud resources that you don't even use, bad for your budget. Today's tools try to solve this, but they are too slow. They try to guess what your app might need minutes from now. Honestly, they often guess wrong, so you end up wasting your money or hurting performance. It feels like you can't win. But what if you didn't have to guess? Meet Escra. Escra is totally different. It doesn't predict the future, it reacts to the present. Escra listens directly to the heart of the system, getting real-time millisecond information. It knows exactly what your app needs right now, and it reacts super fast, giving resources precisely when needed and taking them back when not. The result, you finally break the painful choice. With Escra, you get both. Peak performance, fast, reliable apps your user loves, and huge efficiency, slashing your cloud waste and saving your money. Escra delivers performance and saving. Now my colleague Han Xiao will dive deeper into how Escra achieved this, showing you the architecture details.
Hello, everyone. I'm going to introduce the architecture of the Escra system. As we can see in this graph, we have multiple different components in this system. Now I will go through them one by one. First, we have the application deployer and watcher. It can read into configuration files. Those files always include information about the system, including how much CPU or memory resources we have. And it can also deploy and register containers to the Escra system, so that the system will know there are some new containers coming, and so that the system will be able to monitor them. And in section 3, we have the kernel hooks. Kernel hooks always work as the communication bridge between the kernel space and the controller space. So it can collect per period CPU or memory telemetry data from the kernel space, and it can also intercept out-of-memory events. For the section 5, we have agent process. The agent always run on each host machine, and they can receive commands from the controller. And these commands will be about how to apply the CPU or memory updates. And then it can apply these updates without the containers to restart. And then we have the controller part in section 2. The controllers can handle telemetry data, and they can forward all this data or any event to the resource allocator. And it can also carry out the decisions by the resource allocator about how to reallocate any resources. And it can also reclaim unused memory from the containers. The last part is the section 4, the resource allocator. It can dynamically adjust per container CPU and memory limits to avoid the idle of unused CPU or memory, or some containers be killed from being exceeding CPU or memory limits.
Before diving into the numbers, let me give a high-level takeaway from Escra's overall evaluation. Escra is a container orchestrator that reacts to demand every 100 milliseconds, not every 5 minutes like Google's autopilot. That speed lets adapt instantly to traffic bursts and fluctuating workloads. Instead of trying to predict future usage with machine learning, Escrow just responds to what's happening right now, and surprisingly, that makes it faster and more efficient than autopilot across the board. In microservice benchmarks, Escrow improved latency by up to 38% and throughput by 54%. It also decreased CPU and memory waste by a factor of 10. That's a massive cost efficiency gain. One stat that really stood out is that Escra ran 32 separate stress tests and didn't have a single container crash from an out-of-memory error. That's impressive, and that's especially impressive under bursty and unpredictable serviceless workloads. And this wasn't just a one-time occurrence. Escra scaled both large and long-running services and short-lived serviceless apps like grid search with ease. So in short, Escra isn't just faster, it's smarter, and it's more adaptable than anything container orchestration has seen so far.